When we look at the state of modern construction today, it is fair to say that steel has been the backbone of our cities for a long time now. We have come to see how strong and reliable this metal alloy is. That said, steel has its weakness in that, like pretty much most metals, it rusts. As we all know, rust is not our friend as it costs billions every year in repairs and replacements. In a bid to sidestep such an issue, engineers have turned to this material that doesn't rust like steel. Perhaps even better, it's 4 times lighter yet stronger than you could possibly imagine. This material we are talking about is fiberglass rebar, also known as GFRP or glass fiber reinforced polymer. This material is set to redefine how we build, so it's being used to construct bridges, tunnels, and coastal structures. Indeed, this could be the material that could reshape the foundation of modern infrastructure in the years to come. The raw materials. It might interest you guys to learn that fiberglass rebar is created from one of the most simple substances you can find in this world, silica sand. Once you get a hold of the good stuff, the next step is to melt it at temperatures that exceed 1,500 degrees Celsius in a bid to form thin strands of glass fiber that are thinner than human hair. Once these strands have been created, they are drawn, cooled, and then wound up into massive spools. Once this is done, the strands become the muscle fibers of fiberglass rebar. Once the muscle fibers are created, the next thing to do is to combine them with resin, a thermosetting polymer. This is due to the fact that resin seems to act like the bone that holds the muscle together, and in the process, it ends up binding thousands of glass filaments into a solid, unyielding structure. When the glass fiber and polymer resonate combined together, we get that composite that is immune to corrosion, is able to resist chemicals, and is able to stay strong even if it's in an environment with salt water or an environment that experiences extreme heat. Forming the core. Another part of the process involves pulling strands of glass fiber through a shaping die. This process is referred to as pultrusion, and in this stage, the continuous fibers pass through a resin bath, soaking each strand as thoroughly as possible. Following this, the strands are drawn into a heated die that makes the resin hard. This is done in a bid to form a solid bar of composite material. Once this is done, we get a straight rod that forms the core of the fiberglass rebar. Once we get these bars, each and every one of them is then cooled down before they are cut to length. At this point, you can see how different it is from steel. Light yet sturdy, it is clear that this material is strong enough to bear the load of heavy structures. The surface texture. When we examine these steel rebars, we find that they are able to grip onto the concrete through the ridges rolled into its surface. However, the composites cannot be rolled. Mind you, fiberglass rebar gets its texture from a helical wrap or sand coating that bonds mechanically with concrete. We must also note that while the resin is still tacky, you'd find that industrial sand is applied onto its surface. Once cured, this layer locks the rebar in place when it is placed into the concrete. That way, it prevents any spillage. As such, you may find that the texture isn't just about the grip. It is also about how it gives the rebar its signature hue, thereby making it easy to spot on building sites. Precision cutting and testing. To make sure that every piece of fiberglass rebar is up to par, every single batch is measured, weighed, and tested for their tensile strength, their flexural stiffness, and their bond performance. Thanks to this test, we can make sure that each bar can withstand forces that exceed 1,000 megapascals. This is massive because this exceeds what most concrete structures demand. This is why, despite its lightweight, the tensile strength of fiberglass rebar rivals and even surpasses that of steel. Let us add one more time that it doesn't fall to the whims of corrosion. Once the testing is complete, you will find that only the bars that pass every test are bundled and shipped out for use in the next generation of building, bridges, and highways. Why fiberglass rebar matters. We've touched on this point several times, but we found that corrosion has proved itself to be the covert enemy of most buildings all over the world. Thanks to factors like humidity, salt water, and chemical exposure, traditional steel reinforcement has gradually been eaten away. The situation is even worse in coastal cities, as it has been estimated that 40% of total maintenance costs are caused by erosion. As such, we can see why fiberglass rebar is set to prove itself as a suitable alternative to steel. Thanks to its immunity to rust and corrosion, it is ideal for marine structures, wastewater facilities, and de-icing salt-exposed bridges, thereby extending the lifespan of the buildings and structures by decades. Another factor that comes into play is how lightweight and non-conductive fiberglass rebar is. Thanks to this, you will find that it is easier to handle and it is also safer to install. Furthermore, contractors can actually move it around without having any need for heavy machinery, thereby cutting the costs of construction while also reducing carbon emissions. The science behind the strength of fiberglass rebar. When we look at what makes fiberglass so strong, we found that it is all due to the bond between the fiber and the resin. Turns out that when you look into each glass filament, you'd find that they come with tension thanks to the resin that keeps them aligned while distributing stress evenly. When combined, a structure that is tough but flexible is created, and it is so efficient that it is actually able to bend without breaking. This is far from what steel brings to the table, as steel is known to succumb to fatigue due to the constant vibration or stress it endures over the years. Thankfully, fiberglass rebar is able to maintain its structural integrity many years after it has been installed into the buildings or structures. Unsatisfied with this level or reliability, researchers and experts alike have continued to refine the fiber orientation, resin chemistry, and curing methods. That way, they could make newer generations of fiberglass rebar that are stronger and more heat-resistant than ever before. Applications to the real world. The interesting thing about fiberglass rebar is that it is already changing the way we see construction today. In Florida, for example, it is currently being used in seawalls and docks in a bid to combat the areas where salt sprays have already eaten through the steel that was used there. Then there is Canada, where entire bridges have been built with the use of fiberglass rebar to put the decks and girders together. Let's make our way to the Middle East, where extreme temperatures have taken their toll on steel-based buildings over the years. Thanks to fiberglass rebar, they now have a certain level of stability that could last for decades or more. We must also remember that due to the fact that it is not magnetic, it can also be used to construct hospitals and labs. It is also used pretty much anywhere sensitive electronic equipment cannot be interrupted or disturbed by steel's magnetic field. Thanks to its light, strong, and non-conductive properties, it is a versatile reinforcement fit for the modern world. The manufacturing line. To give us this new and improved fiberglass rebar, we find that a normal fiberglass rebar plant runs 24/7. Thanks to this, continuous pultrusion lines turn raw glass and resin into many miles of rebar every day. Due to this, workers are on it all day as well. They are there to monitor temperatures, speed, and pressure. That way, they could find any deviation that can affect the strength or the consistency of the fiberglass rebar. As these bars make their way from the pultrusion line, robotic cutters are used to slice them up into precise lengths of 6, 9, or 12 meters long. With that, you'd find that every single motion involved in putting this material together is automated for accuracy, and as a result, uniform rods are ready to be moved out and sold to the final consumers. Comparing fiberglass to steel. A direct comparison of fiberglass to steel will show that fiberglass is 4 times lighter than steel, thereby reducing the costs of transportation and labor costs. Despite being lighter, fiberglass rebar has comparable or even superior tensile strength than steel. Most importantly, though, it is also way more immune to rust than steel. Fiberglass rebar is also non-conductive and non-magnetic, thereby making it perfect for specialized structures. That said, we must note that fiberglass has lower elastic modulus. This means that it is less stiff than steel. However, when the proper engineering is applied, the flexibility of fiberglass could prove to be an advantage, especially when applied to areas that are susceptible to vibration or even worse, seismic activity. Sustainability in the future. The sustainability or fiberglass rebar is one of its most attractive features when we think about it. The long lifespan it offers helps reduce material waste. It also reduces that rate at which maintenance and repairs are applied. As such, we also find that factories are increasing the rates in which they are powered by renewable energy. Furthermore, resin formations are shifting more towards bio-based polymers these days. This sustainability is amplified by the fact that GFRP does not corrode or rust. As such, concrete structures can apply less protective cover, thereby saving material and lowering the rate of CO2 emissions. In due time, we will find that cities will come to rely on materials that can withstand both time and climate change. The final product. After the long process, the GFRP is ready for use. Once they are bundled out of the factories, they are fixed into thousands of buildings worldwide. Although we may not see them, many of us now know that GFRP shows how we are making that transition from traditional steel. Theory proving that we are looking for lighter and stronger materials that will last for many years to come. In conclusion, the transformation from grains of sand to the foundation of cities is clear for all to see. We can only hope that this testament to human ingenuity will stand the tests of time as fiberglass erects buildings worldwide.